Here's my video connecting the three forms of quadratic functions. I have a standard form right here. From this we can go to a factored form if we can factor it, okay, which we can. We need two values, two that will add up to 8 and also multiply to 15. Okay, so I know that x plus 5 and x plus 3. So the 5 plus 3 will give me 8, and 5 times 3 will also give me 15. Okay, so that means that these guys will be equivalent. Okay, this tells me that I have two x-intercepts. Okay, one is at -5, 0, and the other is at -3, 0. So the opposite of what it says up there, because we want to plug in -5 to make this 0. Notice the y is 0. I want to plug in -3 to make this 0. Notice the y here is 0. Okay, so I'm going to go over to Desmos. I'm going to add a table. Okay, so I go to this little plus up here. So my lower one, I'm going to say -5. Okay, I know that that's going to be a 0. And then I'm going to just place a marker there. And then I know that -3 is also going to be 0. Okay, so right away I notice that I have one space in the middle. And I know that I should always have an axis of symmetry because of the parabola. So somewhere in there, on the line x equals -4, so somewhere on that blue line, I know that I'm going to have my vertex. Okay, because we started right here with an a term of 1, I know it's going to follow the standard x squared pattern. So I have 1 squared, 2 squared, 3 squared, 4 squared, and so on. Okay, so if I'm 1 away, I go up 1. If I'm 2 away, I go up 4. If I'm 3 away, I go up 9. If I'm 4 away, I go up 16. So here, notice that we're 1 away from the axis of symmetry. So that means to find it, I need to go back 1. So I know my vertex will be there. Okay, -1. Okay. So right away with that, I can write my vertex form. I know my vertex now, so I can write the vertex form. I know that a, we mentioned before, was 1. I have x. Remember that we're always doing the opposite, so we're going to use a +4 for our x value. And then I square that. Okay. And then we subtract 1 to get down to the vertex. So notice how it goes through those points. Okay, so in my table, I'm going to add a few more points. If I add -6 here, we're going to start from our vertex. Remember that we square the distance away from the vertex. So in this case, our vertex is right here. Okay, I'm 2 units away, so I'm going to add 2 squared to my vertex. Notice how that point pops up right there. Okay, if I go the other way, the same rule applies. Okay, I'm now 2 away to the right. So I'm going to take my vertex, which is -1, and I'm going to add the distance that I am and square it to get the point there. So hopefully you can see that we go out 1, up 1, out 2, up 4, out 3, we should go up 9. So let's verify that. So if I'm at -1, I go -1 plus 9, which is 3 squared. Okay, so the next thing I want to note is that according to our standard form, we should have a y-intercept right here at 15. So I'm going to test that. So 0, and then this one would be 15. Okay, notice that that value popped up right on our graph right here. Okay, so from our three forms, we have our vertex form right here, which tells us the vertex. Remember that inside the parentheses, it's opposite. So it's close to the x, so that's our x value would be -4. Our y value is -1. Okay. Our standard form tells us the y-intercept, and that the rate is the same as x squared. Okay, and our factored form tells us the intercepts, so it's the opposite of what's in the parentheses.